Okay, so good afternoon, class. If you can hear me, as we always do, or as we did last week, we're going to just go through the practical tutorial using the software. So if you are ready, just switch on your starter software. Right? Like I keep saying, I may actually ask you questions that relate to the practical, because the practical, your answers should be realistic. That's why we do the practical. So don't take it for granted. It's not something that is trivial. I expect you to take it very seriously. Okay, so those who are taking part in this practical, which all of you are supposed to, but if you ain't gonna do it, pay the price. You can just start it. We are going to do some on-screen digitising and then see how things go. I also sent you a tutorial, a link to tutorial on topology. So we may look at that if time permits. Let's just get on with the on-screen digitizing. So we've already learned the theory behind digitizing and why we do digitizing. We want to convert hard copy maps into soft copy or a digital format. We want to bring it into a digital format. That's why we want to digitize. It's the same thing with scanning. Okay, so, but when we scan, you obtain a picture, let me say an image. Okay, and then when you actually digitize, you create points, so which are actually vector. Okay, they are vector in nature, they are discrete data. In other words, you have a point in between the 2 points, you never know what happens there. When you have a picture, the data is continuous. We always know the value from all the possible. Even then, there's some sort of generalization in there. There's some discrete, an element of discretion in there. There's a lot of generalization that happens with raster image or a picture. Okay, so that depends on how accurate a picture is in representing the real world, depends on the resolution. Is that okay? All right, so it's just recapping and putting into context what we want to do. Okay, so excuse me, you've been given a certain image which I asked you to unzip. Okay, so if I go to your WhatsApp page, you see this FL_ West Palm Beach _ 349056. So that is what we want to use. So if you've not unzipped it, then you have to do it now. Okay. And why is my Zoom looking like this? I have a certain funny view. Okay, view. Okay, hold on whilst I arrange my Zoom. Let me just do it well. Can you see my screen anyway? Anybody can put on their microphone and tell me whether they see my screen. What do they see? What do you see on my screen?
Okay. I see the home interface of yours.
Okay, so you are looking at the interface. Okay, that's good. The QGIS interface. Okay, that's fine. All right, so we get a data and want to unzip it. So that's the first step. And when you unzip it, you will find these files. So let's look at these files, the files that you get from the uncompressed format. So understand that zip is actually a compressed file extension. Okay, so the zip file looks like this. You have so many files, TFW, you have the TIFF file, okay. You have TIFF.aux. AUX actually stands for auxiliary, the aux that you probably see with most sound systems. So it's helping you to connect some devices. So aux means auxiliary, means help. PLJ is projection file, then again. TIFF actually stands for tagged image format. So when you see tagged image format, what do you think it is? It's an image, it's a picture, and it's actually an implementation of the raster data model or concept. Okay, so here you can see that's original file, which has been zipped, which is actually, we have different ways of, you can have the WinRAR, 7Z, there are different compression formats, and they all have their, merits and demerits, okay? So we need to just take one of these. We can just take this one. So obviously, you can see that there are two files in here, okay? We have the PRJ, the geo, let's look at it, the geo cast through all of them, making it the same file. Are you okay? So now let's try to get it open in QGIS. And then we inspect the projection system. So I'm just going to resize my Explorer, or you all have to resize your Explorer. So let me put the steps in the chat. So the first step is to open QGIS. Second step is to unzip your West Palm Beach file. Palm Beach. File. Okay, and then the third step is to open it. Open the file. The file in QGIS. So everyone's supposed to do this. If you have your computer, you're supposed to do this. If you don't do it, it's just doing your own thing. Someday you never know, you may pay a price. I mean, I think the words are wise enough. Wait, so in QGIS, you open QGIS, then you open your Explorer, you have them side by side, but you resize your Explorer. That's if you want to just drag it in. Okay, so you look for a TIFF file. So as long as the TIFF file satisfies the requirement, so I've dropped it into my QGIS. So you should see an image is okay, an image in there. And let's inspect the coordinates. So if you go down there, so you can actually use the zoom tool to zoom into the image, right? And then you have an interesting coordinate system that's not looking like something that you can actually probably relate to. Okay, can I use preferred? So there's a warning up here. Can I use preferred transform between unnamed and that? Okay, so this is what we'll do. You want to close it. This is there are two TIFF files. Let's close this one. Discard it. The reason we're doing this, we are ensuring that our image has a coordinate system, is because we want to make sure that when we actually digitize, then we are actually digitizing based on a certain coordinate. You get it? So that is why we are checking on the code. So before you do on-screen digitizing or any sort of digitizing, whatever you are digitizing should have a coordinate system related to it, because the computer is going to assume that the coordinates that you have in there are going to serve as the coordinate system for your new vector data layer. So I'm relaunching my QGIS. The reason I closed it is because QGIS have that, behavior, undesirable behavior, where sometimes you open a particular file, then it just keeps that coordinate system and it can be a bit misleading. So we can all close it, open it again. We're going to open the other file. So there are two files in here. No, not this one. Should be the Explorer. Okay, I think my Explorer is gone. So let me just get this one for you. Okay, so you can see here that there's this one, it's a file with the _geo, and then we have this other one, _geo WGS84. Okay, so it's assumed this will be in WGS84. So we are learning about coordinate systems as we go. Okay, so most of the things that we learned in class, in theory, we want to learn them as we do the practical, want to also reconcile and make sure they make the things, what we learned make sense. All right, so my QGIS is open now, so I could go back there. So let me just share my QGIS. Okay, so I'm going to this one and I'm just going to drag the second one into it. Hopefully we shouldn't have projection errors. I mean, you don't really want to have an issue with that. Okay. Okay, so here I'm seeing something looking more like, if you look at the coordinates down there, the coordinates look more like your longitude and the latitude. So minus 81.2 and then 26 degrees. So X is minus 81. So we're studying our data. We're trying to understand the data we have, which is the mistake a lot of people will make. Okay, they won't be able to, they will just rush and try to do things with the software and get it wrong. It won't work. So if you have minus 82, let me try to get my whiteboard. Minus 82, so anybody can try to make sense of this. We have minus 80. Oh, okay, with the 20. But I'm trying to read the coordinate and to make sense of the coordinates. 26 minus 80. So this is X, this is Y. Okay, so where in the world is this? Okay, where's the world is this? So we are going to look at it and we're going to make use of, if you have internet, it's assumed you have internet. I'm just going to go to Google and we are going to look for this coordinate. Hey, what happened to my internet? So this isn't going to work. Or is it going to work? Okay, Earth, Google. Okay, so we're going to look for the coordinate and find out if they are correct, just so that we can just learn something from it. So I'm going to be launching Google Earth soon, and we are going to check these coordinates. So we are assuming that the coordinates that we have here are correct. So to refresh, X in terms of longitude and latitude, X is longitude, and then Y is latitude. So X is longitude, Y is longitude, Y is latitude. Okay, so if you have minus 80, so you are west of the equator, so you get negative. You're the left hand side of the Greenwich meridian, so you get x to be negative 80, so you are that far off. And 26 is positive, so it means it's above the equator. Okay, so that's the latitude and it's the y, and it's above the equator. So whichever place we are above the equator, 26 degrees. So let's, for an example, somewhere in Accra, you have 5 degrees, okay, latitude. Okay, so these are things I think you can just play around with it, and then it should be just fine. Okay, I think there's an interesting thing I can also do here. Let me try and add a layer, Google satellite layer, and see what happens. Hopefully, if that merges with it, then that'll be a better example. So I'm trying to add what we call a web map service, which needs an internet to work. So with a good internet, I should be able to do an overlay between Google and my image. So this is a benefit of having a georeference coordinates, Okay. Okay, so I'm going to put my layer on top like so. Okay, so if you look at it carefully, I'm going to change. So whatever I'm doing, you still try and do the same. It's all right, but like I said, if you don't have internet, you can't do this one. Just to show you that our georeference coordinate has become beneficial to understanding and appreciating what kind of data set that we have. So I'm just going to reduce the transparency, the opacity. Opacity and transparency are related, remember? An opaque, 100% opaque objects. Okay, so here you can see that we have a body here, a water body here. And if we take it off, if I switch it on and off, you can see that right there, the edges are even matching. So here, let me try and use my annotation tool. If you watch this edge.
Please, you can see your screen.
Okay, you should have said that earlier. I've told you guys that always tell me if you have an issue. Always talk to me. All right, so I'm back here. Okay, and I'm trying to annotate that if you watch, I've done an overlay, okay, along this edge by simply bringing this Google satellite image. You can see that the edge, if I put this one off, okay, and I even increase the opacity, that red line I've drawn is a common line that is being shared by 2 layers. They are all raster layers. Okay. All right, so let me just clean it. And let me bring the opacity to the normal thingy. I'm going to increase the opacity, apply. So you can do that by going to transparency. So the properties that you can change for a raster image is a bit different from the properties that you can change for a vector layer, which we saw last week from our georeferencing tutorial. Okay, so if I switch on the Google Satellite again, what I want the student to understand is that these 2 images are sharing, they are aligned right where they are supposed to be, and they have something in common. What do they have in common? They all seem to be agreeing in terms of where the water body, this water body is. Are you okay? So I want you to understand that. I've asked questions like that in class, in exams. So please remember, we are not joking. This water body is looking something more like this. Okay, then it kind of goes wrong then it comes back. You see, so you can see that this is what is happening. Okay, and we have whoever has switched on their microphone should, for crying out loud, turn the microphone off, because you too much noise where you are, so you can't be having your microphone on. Simple as that. Okay, tell those you are with that you having a lecture, they should just switch off their TV. All right, so if I switch this layer on, I'll switch this one back on. Okay, so you can see I'm a little bit off, but on a serious note, there seems to be some agreement. Now, the differences might be temporal changes, that maybe the water body is dried up, the dates for acquisition of the beach or whatever, the West Palm Beach, yeah? West Palm Beach, yes. The imagery date and then the map date don't agree. You get it? Okay. So out of curiosity, we could even look at when this was created. And that information, this is actually a map. Can you imagine that? This is actually a map. So our task today is to digitize this map. Our task today, okay? So it was compiled, you see, it's compiled in 1956. So we've started doing analysis, overlay analysis. We're discovering something interesting, that the water body is not the same, yes, after so many years. So that we assume the Google satellite image is more current. This is in 1956. So there's something that has happened to the water body. Okay, so I'm just using the previous one. Okay, so in 1956, the water body seems to be larger than what it is already. So here we can start making a political statement, isn't it? And we can start making noise, you know, something is happening to our water bodies on the basis of just an overlay analysis before we even start looking at what we can do with the digitizing. Okay, so all that we did has an essence. I'm going to just delete the Google satellite image. I just wanted to prove a point that our coordinate system for the data, before you start your digitizing, you should establish a coordinate system, and then you move on from there. This is an on-screen digitizing. And so we have a good data set, okay, with a proper coordinate system. I'm going to increase the opacity so that I can see we can see things properly. All right, now the next thing is to all of you who are taking part, you don't remember I'm doing this because of you. If you are behind, you can let me know, we can discuss. There are all sort of interesting places. So when you look at what we are looking at now, that's quite interesting, isn't it? So this base map of 1956, you know, when Ghana was born, shows interesting places, interesting locations. Obviously, we see there's a water body here, okay, which is actually a lake. Excuse me. So what if we're interested in this lake? How could we do an analysis on it? We'll have to convert it into a vector form. Are you okay? Right. So that is the justification for the on-screen digitizing. It doesn't mean that the data is hard copy. In other words, before you can do an on-screen digitizing, you may want to scan your map into the computer. In that case, you wouldn't need an actual digitizer, okay, digitizing board, with a digitizing pack, etc. So studying this, let me just go a bit closer. You can see all these are actually symbols that have been used on the map to indicate the kind of place that we are, okay? And there's a real line here. So if you look at this line, there is a real line. Let me try to get it for you. Let me get a line. 2. So there's a real line moving in this direction. Okay. You can see the crosses, okay, indicating that we're dealing with a real line. The symbol, yes, a railway symbol. So it's the Atlantic coastline, okay? Then, so now you wouldn't have that. But the reason why we want to digitize, like I said, is because the data at that time, probably computers were not there. The people were not using computers the way they will today. So most things would have been in a hard copy format. All right, so let's inspect it a little bit more, try to understand it. Then we are going to start digitizing it. So there's another lake, okay? And there's a river that links to it, okay? Okay, I see camp here. You know, when you look at places. Okay, so if we actually bring back our satellite image, you will appreciate exactly where we are. So I'm going to bring it back so that we look at it from a certain perspective. So I'm zooming out. My satellite is loading. We want to know which part of the world we are. Okay, are we in the US? Are we in Southern America? Let's see. So as we zoom out, we should get a better view. Okay, so we learn about these zoom out tools, the pan tool, etc. So now we can pan. I think we are at a certain popular place edge. It's not really an island, it's just a protrusion of the landmass, okay, a part of the US. Okay. Of course. That beach resort is a popular one. So the first time hearing about it. Okay, so there you go. So QGIS allowed us to do this. We can also bring in OpenStreetMap as a layer, and that gives us more information. Okay, so all these are actually being served, you know, on the fly. Okay, so this is web map service or web feature service. These are all standards that are being applied. Okay, they are standards, geographic standards, which we are not learning. It's a little bit above this, what we are doing here. Okay, so where were we? We are somewhere here at Florida. Okay, Florida. Our data set has the letters FL, so Florida, okay, West Palm Beach. So we don't even live there, but there's a lot we are again. That's why we're not using the Ghanaian example. That's a good excuse not to use an example in West Africa. Okay, not necessarily Ghana. Okay, so we are going to carry on. We are able to overlay because our data set has been geo-referenced. Okay, so now we can go straight for it. We can zoom to our layer. So right click, zoom to layer. Okay. If you are following this tutorial, feel free to stop me if you get stuck. I'm not in a hurry to go anywhere. We have 10 minutes. If it disconnects, also try and reconnect. Okay, so now we want to look closely at this area and just do some digitizing. That's what we are here for. So what are we waiting for? We are just going to do that. Let's get a zoom in tool. I just clicked on the zoom out tool, but let's count. This area seems interesting to me. Normally, people build around the water bodies, areas that are coastal. Okay, I don't know, for some reason, there's a lot of business that thrive. Okay, around places where there are water bodies. You can see clearly that we have this linear objects. Okay, and this one is also interesting. Okay, look at here, there's something going on there. There's a sugar plant. When you are, anytime you're in the US and you see a sugar plant and just, you're talking about 40 years, I don't know, 60 years ago or something, I don't know, 1956, that's long ago. Obviously, it brings your mind to sugarcane plantations. I mean, it's not a very Funny story. Are you okay? It's not funny at all. Talk about sugarcane plantations. For those who understand, they will understand. That was initially looking to me like some sort of airstrip or something like that, but we'll find out later. The sugarcane plant is connected by the rail line, okay? And there's a sugar camp. I don't know. I think we have to, if you really wanted to understand what is happening here, then obviously you have to read more about it. All right, so we are also within a certain county. We are on the here at the moment on this line. We are between two counties, the Hendrick County. It's just like saying Ashanti region or Greater Accra region, something like that. Palm Beach County, that's where we are. There are areas of vegetation, okay, and then these places look more like they are actually a certain type or class of vegetation, maybe swampy or something. I don't know, but I don't want to take a guess. Unless we, of course, most maps have a legend which can help us to appreciate the symbols being used. Okay, so let's go back twice. Let's get a pan tool, and then there should be a legend somewhere. Okay, let's look at this bottom end. So we are using tools that we learned from last week. Okay, so when we look at this legend, obviously we see roads, hard surface. Okay, so that's a road. When you see the red and white alternating colors, okay, these are route in the US. I think they call it routes or routes. I don't know. 2 lanes, these are roads. So all these are roads. The red lines are routes. Okay, 3 lanes. So when we are digitizing, we will know exactly what to call them. So we need to appreciate it. Thank God we have a good legend. Okay, so what I thought was airport is actually airports. It's a land plane. It's not really airport per se. Yeah, of course. It's a land plane airport. And then there's a landing area. Of course, when you see an anchor, then you look at a harbor or some a seaport or something. Seaplane airports, okay? It's also represented by that. There are power lines on the ground, okay? That is if you did a good job in 1956, you can sit down and then 50 years on or whatever, 60 years on, and then be looking back in time and trying to see what has happened over the years. Okay, so yeah, there are all sort of symbols here, okay, that we can, relate to. When you have this texture of symbol, these green dots represent an orchid. So when we actually digitize an orchid, we know we are digitizing. Or there are woods and brushwoods, which are actually green, given the symbol of green. Okay, so we kind of understand the whole thing to some extent. Okay. All right, so there are boundaries, international, state, county. County ones have long dashes and short. So it's good to appreciate it this way. Then we can go back. You can go, it keeps a history of our view, our map view. So I'm going back so many times. And then I can zoom again to the busy area, okay? And then we can start digitizing some points. Let's start with points. We move in this direction. We move in this order. Points, then we do lines, then we do polygons, then we try to appreciate it. So what points are of interest? We can just zoom a bit closer, and then we can look for points of interest. Yes, we have the airports. We have only 2. Okay, so we can decide to do airports. Okay, so to digitize, it's a very simple process. We'll have to first create a file. Okay, so all that we've been doing so far, we have 4 minutes. You can rejoin when we're done. So step 4, we've been trying to simply inspect the map to be digitized. Okay, so which we've done and we've tried to understand it. Are you okay? Try to understand or interpret the symbols. Understand, interpret the symbols using the pan zoom tool. Okay, so far that's what we've done, and it's very important. We've tried to also understand the kind of coordinate system, okay, that we have. Expect the map to be digitized. Of course, we added it to QGIS. Oh, that shouldn't be. Okay, so the assumption is that we've added the TIFF file to the QGIS. Okay, so we've done these. Okay, we inspected it. We know the coordinate system is WGS 84. If you're not sure, we can just right click the layer. So select the layer, go to properties, and then you go to information, and then you see the coordinate system being used somewhere in the CRS is WGS 84, which is actually a longitude and latitude coordinate system. It's a geographical coordinate system. And so if you know your longitude and latitude, there's nothing to worry about. It means all your coordinates and your final digitized data will be what? WGS 84. They will be in WGS 84. So to actually start digitizing, we go to layer, create layer, new shapefile layer. So layer, new layer. So that was step 6 or so. Layer menu, new layer, new shapefile layer. Okay, so this is how you create a layer. We are creating a new layer. So we talked about layers in class. You can't appreciate it. What is he talking about? Now I'm showing you. If you don't get this one, that's it. Okay, we are going to fail you. No, I'm just kidding. So create layer, new shapefile layer, and then you just see a dialog box with new shapefile layer at the top. So if you can't see that dialog box, you need to draw my attention. If you do, then I think you're happy. You don't have to say anything at all. But the first is to indicate the file name. Now this one is interesting. So simply click on the box, the button at the, it's not a box, it's a button at the far end with 3 dots. Click that. It allows you to specify a file name and then a location for you to save the file. So don't save it anywhere. Save it at a place where you can easily, you can store it in GIS tutorial. Okay, and then you just create a new folder and you give it a name that's relevant. Tutorial, I don't know, GIS tutorial. And you just save it.